thing it's of no use. So kindly please bear with me. If and when I'm calling you to please attend on time, kindly please come to the class on time. Okay, thank you, student. But you are doing that. It's not like that you are not doing. You are excellent, but still a little more. Okay, little more, a bit. Okay, because those students who are joining late, those students are coming at 9:50. Those 3 minutes I can cover, I can continue. Okay, so if anybody is coming late, kindly please revisit the videos. Okay, so thank you, students. I hope the recording has started. Okay, okay, I will start. Okay, so now students, in the last class we were talking about boosting. We saw that boosting means we were talking about multiple base learners in the sequential fashion. All the records were trained, and then when we given the record, okay, then those records which were misclassified, okay, will be going to the another particular base learner, and again that particular base learner will be trained on that misclassified record, and those records which are again misclassified will be going to another base learner. Like that it will keep on going, and then you can repeat the process. Okay, now here we will be talking about adapt boost. Here the only thing is it's a little bit different from boosting. Is weight will be assigned. Now students, step number 1. Consider, students, there are 3 features and 7 rows. 3 features, F1, F2, F3, and 7 rows. And there is an output column. Consider it's yes or no. Now, step number 1 is to assign sample weights. Okay? Is to assign sample weights. The formula to assign sample weights is 1 by n. So, the sample weight for this particular row is 1 by 7. 1 by 7. 1 by 7. Okay, 1 by 7, 1 by 7, 1 by 7, 1 by 7. So 1, 2, 3, 4, 5, 6, and 7. 6 and 7. So this is the step number 1 to assign the sample weights. Okay, then we create the first base learner, which we create sequentially. Here, kindly please understand, here we use in boosting, okay, there can be in whatever may be the type of base learners, and however the base learners can perform. In ADA boost, we use decision tree alone to create the base learner. Okay, and all the base learners what we use, okay, is decision tree. It is not like random forest. It is not like random. Decision tree here is created with only one depth. So what we will do is, since there are 3 features, so we will create F1 with only one depth, F2 with only one depth, and this can be more leaf nodes also. Here I am putting 2 leaf nodes, F3 with only one depth. So we create, okay, this is called as stumps. This is otherwise called as stumps. That is the decision tree with only one depth in the ADA boosting. Okay, for each feature we are going to create. So this is going to create, we are going to create one stump. This is one stump. And this is another stump. Okay, this is another stump. From these stump, we have to select the first decision tree based learner model. How? We can use the concept of entropy or Gini index. But here we will be using entropy. Okay, because entropy is much easier. Okay, so whatever, okay, you can use anything. Okay, but we will use entropy. So now we will be applying entropy for this. We will be calculating the entropy for this. So we can use entropy or Gini index to select the best stump, okay, for the first base learner model. Okay, so entropy, now whichever entropy, we are going to apply entropy on this F1, we are going to entropy for F2, and we are going to apply entropy for F3. Now, we are going to compare their entropies values. Okay, we are going to compare the entropy values. Now, whichever entropy is less value, okay, whichever entropy has less value, we will select that entropy. Now, consider out of F1, F2 and F3, stump F1 have less value. Consider F1 has less value. So now when F1 and F, okay, now in this F1, how many records we have? Consider 7 records. Now, F1 is classifying 6 records correctly and 1 record incorrect. Okay, that is F1 is classifying 6 records correctly and 1 records incorrect. Okay, so what we will do is, okay, 1 second. So what we will do is 1 record incorrect. Okay, so whatever it is, so we have classified 6 records correctly and 1 record incorrect. For that incorrect classification, we find out the total error. For the incorrect classification, we find out the total error. If it has classified 2 records correctly, then we need to do the 2 records. Okay, we need to classify the error for those 2 records. If we classify 3 records correctly, okay, we have to calculate for 3 records. Okay, so how we will calculate is, the error is summing up all the error values. In this case, when we sum up all the error values, it is 1 by 7, since only 1 record has been classified incorrectly. If there are 2 records classified as incorrectly, that is 1 by 7 plus 1 by 7. We are going to sum up, right? That is, the total error will be 2 by 7. Total error will be 2 by 7. Okay, if we are able to, if our system is classifying 3 records incorrectly, it will be 3 by 7. Like that it goes on. So this is how you calculate the total error. Okay, so now the total error, consider for this particular one is, say for example, one particular record have been classified correctly. Say for example, this particular record have been classified correctly. Instead of, say for example, no, the system have classified as yes. The system has classified as yes. Now other thing, all the other features, yes, yes, no, no, whatever it is, the system has classified correctly. Let us consider. Okay, for one particular record alone, the system has classified incorrectly. Okay, now, so since we have calculated the error, which is 1 by 7, total error is 1 by 7 because only 1 record has been misclassified. Now the next step is, we will be calculating the performance of the stump. We will be calculating the performance of the stump. Oh, the formula to calculate the performance of a stump is 1 by 2 log E to the power of 1 minus total error divided by total error. Okay, divided by total error. In this case, substitute the values. Okay, 1 by 2 log base E, 1 minus of 1 by 7 divided by 1 by 7. So which I get 1 by 2 log base E to the power of 6 I will get. Okay, so I will get 1 by 2 log base E. When I do, it is 0.896 is the value. 0.896. So what is the total error value? Total error value we have calculated as by summing up all the error values, which is 1 by 7 for this example. 1 by 7. Okay, so plug in the value 1 by 7, 1 minus of 1 by 7 divided by 1 by 7, I get 1 by 2 log E to the power of 6, 1 by T log E 6. So when I do the math, I get 0.896. Now, why we calculate the total error and the performance of the stump is, we need to update the weights. Okay, and please understand, only the wrong records that have been misclassified needs to be passed to the next stump. Okay, so for that what we will do is, we will increase the weight of the wrong records. We will increase the weight of the wrong records and we will decrease the weight of the correct records. We will decrease the weight of the correct records. Will decrease the weight of the correct records. That is why I am calculating the total error and the performance. So if you see, what is 1 by 7, students? Can anybody tell me what is 1 by 7? What is 1 by 7 value? Hello? It is 0.14, right?
Yes, sir.
So everybody will have 0.14. So the weights is initially is 0.14. Sample weights is 0.14 when we divide. Okay. Now our aim is to the wrong record value weight should be increased and the correct record value weight will be decreased. Okay. So that is our aim. So for that, to increase the weight, okay, to update the weight, okay, of the incorrect classified record and to update the weight of the correct classified record, we have a formula. So to update the weight of the incorrect classified record, the simple formula is weight into e power performance C. Performance C. Very simple. Okay. For the correct classified record, the formula is weight into e power minus performance C. Performance C. Okay. So now when I plug in the value of misclassified records, all the misclassified records I have to say 1 into 7 into, in this case it is 1 into e power 0.896, which is 0.349. Can you see? 0.349. So now when I plug in the weight of this 1 by 7 for all the records, okay, there are 6 classified records, right? Correctly classified records. So for 6 times I am be doing the same thing. E power minus 0.896. 896. Okay. So I get, can you see? 0.05. I get 0.05. So now if you see the updated weights is, okay, I will just write it down one more time here. Okay, quickly I'll write it down. F1, 2, actually I don't have that writing pen. 3, okay, then the sample weights, this is the output. Okay, and this is the updated weights. So sample weight was 1 by 7. 1 by 7. Okay, you kindly please make a note of it in a neater way till all the 7 records were 1 by 7. Now, we told that the second record was misclassified from no to yes. Okay, so what was 1 by 7 value is 0.14. Now you see. Okay, so since we have updated the weights for a wrongly classified record, for incorrect classified and correctly classified. So 0.349. So 0.349. Okay, and for correctly classified record it was 0.05. Okay, so all the other correctly classified records will be 0.05 because here only one misclassified record. So till till 0.05. Okay, so if you see the weight which was 0.14 initially for everybody, the misclassified record has increased in weight. Okay, and the correctly classified record has decreased in weight. Okay, are you people able to understand, students? Are you people able to understand? Quickly raise your hands. How many of you are able to understand? Quickly raise your hands. I don't have time, please. Within 10 seconds. or less than that? Please. I have so much to explain. Okay, fine. So now students, now the next step is, now students, usually if we sum up, this will come around 1. When we sum up the sample weight, this will come around 1. But if we are going to sum up, it is not going to come around 1. So it is coming around, when we sum up these, all the values, it is coming up around 0.649 when we sum up all the values. So the next step is the normalization step. What we will do is divide 0.05 divided by 0.649. Then 0.349 divided by 649. Then 0.05 divided by 649. Then 0.05 divided by 649. Then 0.05 divided by 649. That you have to do. When I do the division, I will get 0.07. Again here 0.07. For all the 6 records, I will get 0.07. 0.07. This is the normalization step. Okay? Dot. Okay, here I will get 0.537. Okay? Now if I be very exact, very precise, okay, then I will get 1 over here. Okay, if I take that minute things into consideration, I will be getting 1 over here. Okay, so now I have got these values. These are my normalized values. So now what I will do is, I will take only the normalized values and I will create buckets based on that. Okay, so how will I create buckets based on that is, I will create, what will happen is, okay, so here, these are my normalized weight, right? So 0 point, I will just try to use, okay, 0.07, again, okay, 1, 2, 3, 4, 5, 6, 7, okay, and then this was 0.537. Okay, so this was my normalized value. Okay, this was my normalized value. Okay, now what I will do is, students, I will create buckets. So I will create buckets of range 0 to 0.07. Now this bucket will start from 0.07 to, when I add up, I will get 0.60. Okay, then when this will start from 0.60 to 0.67. Okay, and this bucket will start from 0.67 to, okay, 0.71, whatever may be the number. Okay, 0.67 to 67 plus point, you do the math. Okay,
0.74.
74. Okay, 74. And then from 0.74, okay, finally this bucket will have from 0.88 to 0.95. Okay, students, so that's it. After normalization, you will be creating a buckets like this. Okay, you will be creating a buckets like this. Now students, now which bucket has the highest range? So when I put a random values, right, of these two buckets also, 0.74 to 0.81 and 0.81 to 0.88. Now students, out of these ones, which bucket has a maximum wider range? If I give a random value, okay, if I give a random value between 0 to 1, say for example, which bucket has a maximum wider range? Which bucket has a maximum wider range of values?
Second bucket.
Second bucket, right? Can you see? Second bucket has a wider range. So the probability of falling into this bucket, the records, okay, say for example, if I'm going to run the iteration with the random values, say for example, since we are having 7 records, I'm running with a random value, okay, I'm running with a random value Okay, I will just okay. So if I'm running with the random value, say for example 0.43, a random value, okay, then 0.21, 0.021, okay, then a random value 0.31, okay, to select a particular bucket, okay, so that I can pass to the next stump, okay, then 0.47, okay, then 64, okay, then 0 point thing, okay, so whatever may be the value, since my bucket, this particular bucket has a wider range, so the probability of this particular record getting selected out of the 7 records based on this random value is more than the others, agreed students, yes or no, agreed, hello,
Yes, sir.
yes, yes.
Yes, sir.
So
Yes.
now this particular record will be moved on to my next base learner. If I'm moving 7 records or 8 records or 10 records, if how many hour iterations I run, and I'm try to create another data set with same F1, F2 and F3, this particular record coming repeated based on this particular data set will be more, okay, than the other 1 or 2 records which will be selected. And then once this particular record is moved based on this particular data set, again I will be creating F1, F2, F3. Then again I will be calculating the entropy based on this particular record. Then again I will be doing, okay, the particular error. Then again I will be calculating the misclassified. Again I will be doing the performance, say, of a misclassified and classified. Then again I will be getting what? Again I will be getting, okay, the updated values. Then again I will be doing the normalized values. Then again I will be creating a buckets, and again from that particular bucket, whichever record has the wider range of values, that particular probability will be chosen more of falling into another data set, and I will be repeating this again and again, and I will be passing it to multiple decision tree based learners. This is all about data boosting and how it works. Is it clear to everybody? Is it clear to everybody? Hello? Is it clear to everybody?
Yes, sir.
Any doubts? Any doubts? Any doubts, students? Any doubts? Okay, fine. Very good. Okay, now students, now I will be moving on to a next methodology called as a stacking. I want you to explain about K-cross validation, because K-cross validation also comes a part of, the concept of K-cross validation is used for stacking also. K-cross validation. Now I'll be a little bit faster because this is an easier concept. Okay, so here student, the problem with splitting of training and testing data. Say for example, usually what do we do, students? So if I have a data set of 100 records, say for example, so usually we go for 20%, 20% testing and 80% training. Yes or no? This is a normal regularized concept. Or sometimes people go for 25% testing and 80% training. Okay, whatever it might be, a small light fluctuation is there always. But a very good model to get a better result, we need to maximize our testing data also percentage, and we need to maximize our training data percentage also. We need to maximize our testing data percentage also. But if you think that I can move this part of the data to over here, say for example, if I want to make, say for example, 50-50, it's not a better way. Why? Because we are compromising on training data such that this 30% might have more information. We never know, right? If you are going to divide 50-50 or 60-40. Okay, then what? Then we are missing a part of the data. So that's not a good way. So we are going for the concept of gray cross validation. How it works is, say for example, students, let's consider we have a data size of 200. And what we will do is, we will create a bucket of 10. We'll create a K bins of 10, of size 10. What we will do is, each bin will have 20 records. 20, 20, 20, 20. Like that, how many bins will be there? 10 bins will be there. So 10 into 2 is 20. 10 into 20 is so like that. So how many bins will be there? 1 to 10 bins. So 10 into 20 is 200. Okay, very simple. So our record size is 200. I have created a bin size of 10 K folds. Okay. Now what I will do is, in the first run, the iteration will run for 10 times. The iteration will run for how many times, students? 10 times. The iteration will run for 10 times. In the first run, I will treat this as my test data. The other 9 records, I will be treating it as training data. I will be treating as training data in my first run. Then in the second run, I will treat, okay, this is 1, and from 2 to 10, I will be treating it as training data. In the second run, 1, 3 to 10, I will be treating it as training data. The bin number 2, I will be treating it as testing data. Okay. In the third run, bin number 3 alone will be chosen as the testing data. 1, 2, then 4 to 10 will be treated as training data. Then the same thing will continue. Finally, in the last run, the 10th bin, this 10th bin will be treated as the testing data, and 1 to 9 will be treated as training data. By doing this, okay, so every bin will have, so for every run, 1 bin will be for testing data, and K minus 1 bins. K minus 1 bins will be for training data. So if 10 is means, so 10 minus 1. So 10 minus 1, 9. So at that point of time, 9 bins will be used for training, and 1 particular bin will be used for testing. 1 particular bin will be used for testing. See, and the problem with this is the computation time, because we need to go for what? Students? The computation time is becoming more. But the accuracy, since all the entire data is involved in testing as well as in training, so the accuracy becomes more. But if I increase the value of K, say for example, if I increase the value of K as, say for example, 200, if I increase the value of K as 200, then what will happen? Then how many bins will be there? 200 bins will be there, individually one data point. So 1 data point will be chosen for testing, and other 199 points will be chosen for training. 199 points will be chosen for training. Then the second point will be chosen for testing, and the other 199 points will be chosen for training. Then in the third run, so the algorithm will run for how many times? The algorithm will run for 200 times. So if I increase the advantage of this method, okay, if I put the K values become very large so that all the points is chosen for training, okay, the error is definitely going to be less, but it will lead to higher variation in testing model. Another drawback is it takes a lots of execution time. So this point is called as a leave one out cross validation. So if I make K value as very high, leave one out cross validation. But if I stick K as 10, then it is called as K-fold cross validation. If I take as K as 10, 10 is the appropriate value, or less than 10 is the appropriate value. Simple example, students. So I will explain you the same thing with the help of an example. Let us consider. You have 1, 2, 3, okay, 4, 5, 6, 7, 8, 9, 10, okay, then dot till 15th, till 15, till 15. Okay, students. Now, when K, I'm choosing it as 3. K, I'm choosing it as, 5. K, I'm choosing it as 5. So what I do is, this will be one bin. Then 4, 5, 6 will be my another bin. 7, 8, 9 will be my another bin, third bin. 10, 11, 12, fourth bin. 13, 14, 15 will be my fifth bin. Yes or no? Now, what I am going to do is validation set, training set, and error, MSC error. So how many iterations this particular algorithm will run? 5 iterations, because K is 5. So when I am running, so this is value of K equal to 1. We can say K is, this is, we can call it as, okay, 1, 2, 3, 4, 5. K equal to 1, K equal to 2, K equal to 3, K equal to 4. Okay, this is just to make you understand. So step number 1, when I am running my first iteration, my validation set, that is this set will be these 3 values. Okay, this will be K1, K equal to 1, and my training set will be K equal to 2 plus 3 plus 4 plus 5. 2 plus 3 plus 4 plus 4 plus 5. Okay, 4 plus 5. Then when K equal to 2, in my second iteration, I will take the kth bin, this particular bin as my validation set. Then my training will be what? 1 plus 3 plus 4 plus 5. 4 plus 5, my training set. Okay, when I take K equal to 3 in the third fold, my training set will be K equal to 1, 2, 4, 5. 1 plus 2 plus 4 plus 5. It's 1 plus 2 plus 4 plus 5. Okay, 1 plus 2 plus 4 plus 5. The same way, when I take K equal to 4, it will be 1, 2, 3 and 5. When I take K equal to 5 as my testing set, okay, then what will happen? So 1, 2, 3 and 4. Okay, now when I take, say for example, in this, it is 3 records, right? X1, let us say X1, X2, X3. This is my training set, testing set, validation set. Okay, and we have Y1, Y2, Y3. Okay. Okay, this is my data and this is the expected. But when I put it into my training set and test it, I get what? I get Y1 hat. I get Y1 hat. I get the predicted value. I get Y2 hat. And I get Y3 hat. I get Y3 hat. Now what do? I calculate the difference if it's a logistic regression, how we have calculated, right? So I calculate the error rate. So I calculate MSC for this. I calculate the MSC for this. I calculate the MSC for this. Okay. Then I calculate the MSC for this. Mean squared error. I calculate the MSC for this. Then I take the average of all these 3 values and I get the MSC1 for this particular iteration. The total error for this particular iteration. For this particular iteration. The same way I will do for this. Okay. 4, 5, 6, Y1, Y2, then Y4, 5, 5, Y6. then y4 cap, y5 cap, y6 cap, then I get the MSc error. Then I will take the average of this. Then this average, I will put it over here. So then what do? I get 5 errors. I get 5 MSc errors over here. MSc. I get 5 errors. So the estimate for the test error is, the formula is 1 by k equal to I equal to 1 to k into MSE of I. But as k is the number of iterations or the value of k. So totally 5 bins. So 1 by 5 equal to 1 to 5. So all these, this particular average I am taking, this particular mean value I am taking. So that will be my estimate for test error for k-fold cross validation error. So estimate test error for k-fold cross validation. K-fold cross validation. Okay, this will be my estimate. Have you people understood this? How I am calculating? Yes? Hello?
Yes, sir.
Mobile teacher.
Any of you able to understand? Raise your hands quickly. Okay, so the last topic, what we will move on is, okay, is stacking. So stacking is also an assemble technique. Okay, stacking is also an assemble technique, students. So basically, students, what happens in stacking is, okay, so I use the k cross validation technique, what I have just explained to you now. Okay, so we split the test into train set and test set. Okay, so the training set, okay, for every iteration, I told you, right? If the value of k, say for example, if I'm going to take k as, say for example, if I'm going to take k as 3, so 1 and 2 will be taken for a training and 3 will be taken for testing. Then in another run, 1 will be taken for a training, 2 and 3, 1 and 2 will be taken for training, 3 will be taken for testing. Then 1 will be taken for testing, 2 and 3 will be taken for testing, training, and then 1, 2 and 3. So 1, 2 and 3. 1 and 3 will be taken for training and 3 will be taken for testing. Okay, so that how, so say for example, I am taking this particular model. First run, k equal to 3. So I am taking first run. So 1 and 2, training. So training set will be given to random forest. Training set will be given to multiple classifiers I am combining. Okay, will be the same training set will be given to Navy's base. Same training will be given to K nearest. Same training set will be given to, in the first iteration, SVM. Same training will be given to another concept called as a gradient boosting. And this same training will be given to ADA boosting. So now this will predict, right? It will predict some kind of an output. Okay, so this will predict some kind of an output, 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 this will predict some kind of an output. This is for first, when k equal to 1. When k equal to 1. When k equal to 2, okay, what will happen? 2 and 3 will be training set and 1 will be testing set, right? So 2 and 3. So based on 2 and 3, again random forest will be trained. Navy's base will be trained. K nearest will be trained. SVM will be trained. Gradient boosting will be trained. ADA boosting will train. Again, you will get this predicted value, 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 this predicted value. Yes? Okay. Then again in the third fold, 1 and 3 will be trained. Will be training set and 2 will be testing. And 2 will be testing. Yes or no? 2 will be testing. So this 1 and 3, based on this 1 and 3 training set, again we'll be giving to random forest, Navy's base, KNN, all those things. Again we'll produce based on 1 and 3, again it will produce the predicted value. 1 and 3 predicted, 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 predicted value. Now, based on this particular predicted value of all these training of these different models, whatever the values it has predicted, this is k equal to 1, k equal to 2, k equal to 3 for this particular example. This itself will form a training data set, input training data set, and it will be given to another model called as an, say for example, another MN model. Now, this particular model will be trained on these features. On these features. Okay, this particular model will be trained on these particular features. Now, testing set. Now, coming back to the testing set. Okay, so we will be taking in the first iteration, right? So this was the testing set. Yes or no? Now, when I am testing on this, now it will we'll apply it to this model. Again, we will get some predicted value. Yes. Again, for the second fold, this was the testing set, right? Again, we will be setting this one. Again, we will be putting it over here. Again, for this one, this was the testing set, right? One was the testing set. So again, we will be doing, again, this will be predicting some values. Okay. So now you have the training set which you have trained on this value based on logical regression. And again, you have the predicted value based on the testing set. Now this will come from here. Now when this input is given based on this set, the final label what we get, we will be treating it as the final output label. This type of concept is called as stacking. This type of output is called as stacking. Okay. You are able to understand? You are able to understand, students? Hello? You are able to understand?
Yes, sir.
Yes, sir.
Okay. I will just explain you quickly with the help of an example. Okay. Just give me 3 minutes. I'll be explaining you with the help of a quick example. Consider, students, you have some data set. Okay. X11. Okay. X12. Dot till X1D. Then X21. Then X22. Okay. Then dot till X2D. Okay. Then we have till Xn1. Dot till Xnd. Okay, students? Fine. Now we have the corresponding label for this particular column. Consider Y1, Y2, and Yn. Okay. Now students, consider we have 3 models. Model 1, Model 2, Model 3. Okay, students. What we will do is we will train the models on the entire training data. We will train model 1 on the entire training data and entire training data, whatever I have told you. Okay. Then consider we are training. Now the test record is coming. We are predicting the values on this particular model. So we get, say for example, Y11 cap. Okay. Now again, this particular thing is given to this Y12 cap. Say for example, this is Y12 cap. Okay. Again, this particular thing we are giving it to model 3. Okay. Then Y13 cap. Okay. Then the same thing. We will train again this particular thing on this particular model. Then we will get Y21 cap. For example, Y21 cap. Then Y22 cap. Okay. Then Y23 cap. Okay. Okay, why 2 2 cap and why 2 3 cap? 2 3 cap. Okay, again when we train this particular model, then again we will get y n1 cap, n2 cap, n3 cap. Okay, so something like this we will get. Okay, now. Okay, so this particular data set we are going to give as an input to another model called as an M4. This itself becomes a separate training data. Okay, this becomes a separate training data for another model called as an M4. So this model is given as an input to M4, and this M4 will get trained on this particular model. Will get trained on this particular model. Now what you do is, now the test data is given. Now the test data is given to model 1. It will produce one output. Now the test data is given to model 2. It will produce an output. Now the test data is given to module 3. It will produce an output. Now this will be given as the test data to this model for again the predicted values. The predicted values. So the training data is there, testing data is also coming from the predicted values. Now this particular output is treated as a final output. So M1 is trained on the predicted values of the previous. Can you see? Where is that diagram? So this particular model, logistic regression, say for example in this case, is trained on all the models of the predicted values in every K cross fold. This kind of concept is called as stacking. It's called as stacking. Is this very clear to everybody? Kindly please put how much percentage you have understood in today's class. Okay, out of 10 in the chat box immediately, please, and then you can leave.